When designing a substructure for a floating offshore wind farm, it's important that the design can stand the test of time, can take the fatigue with so many tons on top and so many tons in the sea.
Fatigue is the accumulation of damage in the structure. So you can imagine an offshore structure constantly being hit by waves and winds. And these loads cause a small micro damage to the structure. And these damage accumulates over time and eventually the structure will fail. At the moment we are working on a research project to assess fatigue life of offshore structures accurately. We are particularly interested in assessment of fatigue life of offshore wind turbines.
And what we are doing here is we want to reduce the uncertainty of these estimated wave loads that will be used in fatigue analysis of offshore wind fixed and floating structures. Currently in our testing facility, we have a model of a monopile with a scale of 1 to 40, and we want to see how the wave is hitting the piles and trying to capture the wave load around these piles. The wave load data that we gather from our physical modeling will serve as a benchmark data to validate and calibrate our CFD model, as well as ensuring confidence in the calculated waves, and finally produce an accurate estimation of fatigue life of a structure.
The fatigue life currently is calculated by using low fidelity models. The problem with these models is that they work fine if you are operating within the assumptions that was used to derive those equations, but as soon as you deviate from that, they won't give you very good results. So instead of relying on these assumptions and these simplified models, we are using computational fluid dynamics, which solves the exact equations that are governing the fluid flow without any further assumptions. And that gives us the correct loads on the structures under any circumstances. After calculating the wave loads, now we need to do finite element analysis. Finite element analysis is the standard method to calculate the corresponding stress within the structure. So we have the wave loads which induce a stress in the structure, and finite element analysis allows us to calculate that stress. With that data, we can then go ahead and calculate the accumulation of the damage within the structure, which then can be ultimately used to assess the fatigue life of any offshore structure.